Hey 8th graders, welcome to our new unit, Gravity. So this is going to be a pretty short week, maybe week and a half unit. And we're going to kick it off today with one of my favorite activities that we do all year called Your Weight on Other Worlds. I think kids really kind of think this is interesting to see. If you guys were to go to Jupiter, how much would you weigh and why? Okay, so your learning targets for today: I can relate the mass of a planet to its gravitational force. I can differentiate between mass and weight. And I can describe the relationship between weight and gravitational force. So the first thing we're really going to focus on today in this lesson is the difference between mass and weight. Okay, so just to get you guys kind of kicked off into this whole concept of gravity, which should be fairly familiar to you guys are going to watch two videos. Okay, the first one is called Felix Baumgartner Supersonic Freefall from 128,000 feet. So the video looks like this. And you guys get to watch kind of an adrenaline junkie, to say the least. He went outside of the Earth's atmosphere and basically skydived. So you guys can kind of see a little montage of his experience jumping from outer space. So you guys also kind of get to see that there is gravity from Earth that we can feel in outer space. Okay, outer space is not gravity free. Okay, so you guys will get a feel of that. It's a really cool video. It's just kind of for fun. So once you guys are done watching that, then obviously you guys will need to pause this video, and then this one's the important one. So this really, again, focuses in on that, what's mass and what's weight, because they're not the same thing, and I kind of mentioned that in our force unit. Now you guys get to find out why they're different and how they're different. Okay, so go ahead, pause this video, go watch that video, and when you come back, we'll talk about it really quick. All right, so you guys should have learned about Jeremy and why his mass and his weight are two different things. What we found from that video is when we say mass, we're talking about how much matter makes up an object. So if we're talking about the mass of a human body, how many atoms and molecules come together to make up that body. Weight, on the other hand, depends on gravity, and we actually use a formula, weight equals mass times gravity, to figure out the weight. Okay, so gravity is really important. Not only do we take how much stuff is in our body, but we take how much gravity is pulling us down, and that's our weight. So when you guys step on a scale, you have gravity pulling you down on that scale. Okay, if you guys were to move that scale to the moon like Jeremy did, there's less gravity, and so there's less force pulling him down onto that scale, so it appears that he weighs less. But nothing about Jeremy's mass has changed. He still has the same amount of atoms and molecules that make up his body. So that's the big difference between mass and weight. Again, mass is how much stuff makes up your body, versus weight is how much gravity is pulling you down. Okay, so with that being said, we're gonna start by taking a look at what's your guys' mass. Okay, let's talk about all the atoms and molecules that make up you individually. And I'm going to use my weight and my mass as an example for this. Obviously, when you guys do this, you're going to use your weight and your mass. So question, are weight and mass the same thing? And as you just found out, no, they are not. Okay, people use the terms weight and mass interchangeably all the time, but should they? This investigation will lead you to evidence that answers the question above. First, you will need to calculate your mass. So again, that's not something you guys can get from going and standing on the scale. Okay, remember, mass is the amount of stuff or matter in an object. To convert your weight to mass, you will first need to convert your pounds into newtons. So newtons, as we learned from the last unit, is a measure of force. So when we talk about gravity pulling us down, that's a force. So how much is gravity pulling you down? So we're going to go ahead and take our weight and convert it into our SI unit for weight. We actually don't use pounds for the SI unit. We use newtons, as again, weight is a calculation of force and how much gravitational force is pulling us down. Okay, so to do that, we're going to go on to slide 4. Step 1, take your weight in pounds and multiply it by 4.4482. This will tell us your weight in newtons. So you guys can either do this by typing, or you guys can do this by using the draw tool. I'm just going to use the draw tool because it's easier for me right now. Okay, so there is a calculator on this as well for you guys. If you guys go ahead and right click this link, you guys will see a calculator that looks like this. Okay, so I'm again going to use mine, and I weigh 145 pounds. Okay, if you guys don't know, okay, take a guesstimate. Okay, ask your parents, ask someone around you, like, what are you, like, you're about the same size as me, what's your weight? Okay, or if you guys are really not certain, you guys can just grab a number that you think might be a good enough guesstimate, or you guys can use mine as well. So I weigh 145 pounds. So I'm going to take that mass right there and I'm going to multiply it by 4.4482. Okay, so you guys need to show your work on this slide. So I'm going to go ahead, go to my calculator, 4.4482 times that by 145 pounds, and this is going to be my weight in newtons. So I weigh 644.99 newtons. Okay, you guys can round to 1 or 2 decimal points is fine. So 644.99. 644.99 newtons. Okay, and note that it says circle your answer for step 1. So here's my answer for step 1. So I'm going to circle that. Okay, then what I'm going to do is I'm going to take my 644.99 newtons, and I'm going to see what I need to do with that next. So this is, again, how much gravitational force is pulling me down. So to convert from newtons to kilograms, which is our mass, we're going to use the formula weight equals mass times gravity, where W is the weight in newtons. Okay, M is the mass in kilograms, and G is the acceleration due to gravity of Earth. So on Earth, our gravitational pull, or our acceleration due to gravity, is 9.81 meters per second squared. So basically, I'm going to take my weight in newtons and divide it by the Earth's gravity to solve for the mass. Okay, so 644.99 divided by 9.81. That's my gravitational force on Earth. So I'm going to go ahead and divide divide this by 9.81. And that's going to give me 65.7 kilograms. Okay, so it's equal to 65.7 kilograms. And again, I should be doing this on the next slide. Sorry about that. So 644.99, I did this on the wrong slide, divided by 9.81 is gonna give me 65.7 kilograms. Okay? So basically, if I look at all the matter that makes up my body as Ms. Crawford, okay, all the atoms, all the molecules, I'm going to add them up, and they're going to have a total mass of 65.7 kilograms. If I go to the moon, I am still made up of the same number of atoms and the same number of molecules. So if I go to the moon, my mass is still 65.7 kilograms. So let's talk about the first spot I need you guys to put this information. So I'm going to actually have you guys skip down to slide 9, okay? Notice in slide 9 that you guys have this first column here is mass in kilograms. So on Earth, I have a mass of 65.7 kilograms. If I go to Mercury, remember again that mass is how much stuff makes up my body. I haven't changed that, okay? I haven't lost an arm or magically lost a lot of weight, okay? Or lost a lot of mass out of my body. So if I go to Mercury, I still have a mass of 65.7 kilograms. If I go to Venus, I still have a mass of 65.7. I have not lost anything from my body. If I go to the moon, just like Jeremy, I still have a mass of 65.7. If I go to Mars, I still have a mass of 65.7. I hope you guys get the hint that it doesn't matter what planet I'm on, I am going to have the same mass, okay? Unless in some point I lose an arm in transit, okay? I have the same mass. I am made up of the same number of atoms and molecules and matter. I have the same mass no matter what planet I am on, okay? So this whole first column should all read the same thing. Feel free to copy and paste. Obviously, you guys are going to put your mass in there, okay? With that being said, let's look at the rest of this. We need to find out my weight because weight depends on gravity. Remember, weight is equal to the mass times the gravity, okay? It's how much gravitational pull is pulling us down. Okay, our weight is going to be different, okay? We're not going to have the same weight. On Earth, I weigh 145 pounds. But when I go to Mercury, because Mercury has a different gravitational force, I'm not going to weigh 145 pounds. So think of this. Do you think I'm going to weigh less if I go to Mercury? Or do you think I'm going to weigh more if I go to Mercury? Okay, So for this next part, you guys are going to use this link right here. So if you guys go to slide 7, now go to the following link, your weight on other worlds. Enter your weight in pounds or your estimated weight in pounds if you guys aren't quite sure what your weight was. Record your weight on Earth in the table below. You guys obviously want to use the same weight that you used to calculate your mass on the first couple of slides. Okay, so let's take a look. This is your weight on other worlds. I'm going to go ahead and type in 145 pounds right there, and I'm going to hit calculate. And when I hit calculate, what I should see is I have all these planets here, and it tells me how much I would weigh in pounds on each of these planets. So on Mercury, I would weigh 54.8 pounds. So if you guess that I would weigh less on Mercury, you're right. So 54.8 pounds. On Venus, how much do you guys think I weigh? More or less than on Earth, okay? Let's take a look at the moon. Okay, if I go to the moon, my weight is 24 pounds. I want to go to the moon. Just kidding, that's a little too light. Okay, what about Jupiter? Jupiter's one of our larger planets, so let's take a look at that. If I went to Jupiter, I would weigh 366.5 pounds. Oops, 366.5. So what you guys will do is obviously using your weight, you guys will go through and fill out this information. Okay, then if we look at the next one, we have the same stuff here. So our mass, my mass is still the same if I go to any of the moons of Saturn or Jupiter, okay? My weight's going to be different though, so you guys will look down here and say, all right, if I go to the moons of Jupiter, here's Io, Europa, Ganymede, and Callisto. You guys can see the weights there, okay? So you guys can kind of see how they compare, and you guys would put that information in right here. Doesn't matter what moon I'm in, I'm going to have the same mass, but I will have different weights, okay? And then finally, let's just take a look at our last table. We have your weight for the sun, a white dwarf, and a neutron star. So again, you guys would look at this and go down a few types of stars. Here's the sun. If I went to the sun and could survive on the sun, I would weigh 3,925.4 pounds. A white dwarf, you guys can see, and a neutron star. Those are some pretty hefty numbers as far as weight. So what does that tell you about the gravitational force of those objects, those planetary objects? Okay, so from there then I need to find out my last little column for slides 9 and 10, or tables 1 and 2. I need to find out the equatorial radius. Fancy pants way of saying that, I need to find out how big those planets are. Okay, so for this one, you guys are going to go to slide 8. You guys have a link right here. It says right here, click on planets and then by the numbers. So I'm going to go up here, I'm going to go to planets. I'm going to choose what planet I want. So I'm going to go ahead and choose Mercury. Actually, I'm going to choose Earth first. Okay. The great thing about this is it's easy to navigate once you guys are in it. So I'm going to click right here by the numbers. And then what's great is you guys will be able to compare Earth to another planet. So you guys will be able to collect data for more than one planet on the same screen. So right here we have Earth versus Jupiter. So I have 2 planets right there that I can compare. Okay, I'm going to scroll down and by the numbers until I see equatorial radius. So remember, radius is like the half. So if we take a circle, which most of our planets are fairly circular shaped, if we take half of that, like straight from the outside to the middle, that's the radius. So that kind of gives us a big idea of how big or small those planets are. So Earth has an equatorial radius of 6,371. So in my sheet here, I'm going to go into Earth. And Earth has 6,000, what did I just say? 6,371. Has an equatorial radius of this, but I also have Jupiter's right here as well. Okay, so Jupiter has an equatorial radius of 69,911. So 69,911. Okay, so you guys can see how much bigger Jupiter is compared to Earth. So you guys can go ahead, you don't have to go back to the main screen. You guys can actually just go up here and navigate through here and say, all right, I want to go to Mars. Okay, it'll show you guys Mars is, so you guys can see Mars is smaller than Earth. So let's go to the equatorial radius. You can see it's 3,389.5. So Mars, 3,389.5. Okay, so you guys can go ahead and finish filling out this data for your equatorial radius. Okay, and then what you guys will do is once you guys have had that done, you guys will do the same thing for the moon. So I just want to show you guys one last thing. Obviously, you guys are not going to find the moon under planets because the moon is not a planet. So you guys are going to need to go to Earth's moon to find that information. Okay, by the numbers as well. And then you guys can go find the equatorial radius of the moon also. So the moon's equatorial radius is 1,737.5. So 1,737.5. Okay, and then same thing for your moons of Jupiter. You guys need to go find Io, Europa, Ganymede, and Callisto. Again, go to moons. Those are Jupiter's moons. And then in Jupiter's moons, you guys can find the moons you guys need. So here's Io. Okay, and then you can go to by the numbers. And then from there, you guys can scroll through and find the other 4 moons. So Io versus Earth. You guys can go through and find Europa, Ganymede, and Callisto all in there. Okay, and find out their equatorial radius as well. Okay, so go ahead, fill in your weight and your equatorial radius for those. And then what you guys see is based on what you guys learned on your weight in other worlds, you guys kind of got to see how much you weigh on the sun, a white dwarf, and a neutron star. Okay, based on what you guys kind of observe for patterns in these here, like for instance, if we look, all right, on Earth, my mass is the same. Okay, my weight is 145, and this is the equatorial radius. But if I compare it to something smaller, like the moon, okay, notice that my weight is smaller and my size of the moon is also smaller. But if I look at Jupiter, Jupiter's huge, and I also have the hugest weight there, the largest weight there. So with that being said, you guys are going to use that information of those relationships to kind of tell us, all right, if my weight is this on the sun, and I were to rank the sun, the white dwarf, and the neutron star from biggest to smallest, which would I rank the biggest, okay? 1's going to be your smallest, 3 is going to be your largest. So out of those 3, based on your weight, which one of those do you think is the biggest? Mark it a 3. Which one do you think is the smallest? Mark it a 1. Which one do you think is in between? Okay, mark that one a 2. So in this one, you guys are going to have a 1, 2, or 3 ranking based on what you guys observe with your weight, okay? What does the size or your weight tell you about the size of these planetary objects, okay? All right, finally, you guys are going to go back to your weight on other worlds. You're going to scroll to the bottom, and you're going to read this section called What's Going On. Okay, from there, you guys will find the answers to these questions, and then also from your data, you guys will have the answers to these. So based on the data you have in tables 1 and 2, what patterns do you observe? List at least 2 patterns you guys see. Okay. Based on your patterns you have discovered, give the predicted mass ranking to each of the type of stars above in table 3. We've already just talked about that. Again, you guys should have them labeled either 1, 2, or 3 based on what size you guys think they are in comparison. And then again, from the weight on other worlds, the what's going on, read about that. Answer, what is mass? Do you have gravity? Why don't you and your friends stick together the way you guys are held to the earth? So you guys stick to the earth, but why don't you guys stick to your friend? Okay, if you have gravity. Okay, and then the next slide. What is weight? Describe the relationship between gravitational force and the masses of objects. So hint, if you increase the mass, what happens to the force? So think gravitational force. Describe the relationship between gravitational force and the distance from the center of the planet or the planet's radius. So hint, if you increase the distance between objects, what happens to the force? And then finally, if Jupiter's 318 times more massive than the Earth, why didn't you weigh 318 times more? Okay, so think about that. Okay, with that being said, once you guys are done with that, you guys can go ahead and hand in this assignment. And I hope you guys are having a great day. Thanks. Bye.